Eons ago, people looked up into the sky, mystified by the flying creatures above. With the aircraft inventions made and designed by the aeronautical engineers, they made the longest term of flight possible. Learning aviation and aeronautics is really fun and exciting, isn't it? First, let me call Don Revisito from the oldest times to present the key inventors and pioneers of aviation. Hello instructors, my dear friends, and my fellow students. Straight back from 1700s, where Jacques Alexander Cesar Charles invented the balloon and traveled nearly 48 kilometers in a balloon called Charlier. Sir George Cayley, the father of aerial navigation and a pioneer of aeronautical engineering, discovered the four forces that act on an airplane, which is drag, weight, lift, and thrust. He also designed the first glider that carry human aloft. In 1842, William Samuel Henson patented a design of steam-powered monoplane, which he called aerial steam carriage. Otto Lilienthal, who developed a dozen models of monoplanes, wing-flapping aircraft, and two biplanes. His gliders were carefully designed to distribute weight as evenly as possible to ensure a stable flight. In 1903, Wilbur and Orville Wright, otherwise known as the Wright brothers, were the first to claim the sustained, powered, and controlled flight. They created a propeller to provide airborne thrust and built a lightweight engine to power a twin propeller system. The culmination of their endeavors was happened on 17th of December 1903 at Kitty Hawk, when they made 4 controlled flights ranging from 12 to 59 seconds. Well, in fact, Lilienthal's research was well known to the Wright brothers, and they credited him as a major inspiration for their design to pursue manned flight. Aside from these mentioned aviation pioneers, we also have Madeleine Sophie Blancard, Bessie Coleman, Charles Lindbergh, Frank Whittle, and Amelia Earhart. Now, I'm 100% sure that you asked this to yourself. How do airplanes fly? Before that, we will go back to the earliest times when George Cayley gave this idea. There are 4 forces that act in an airplane while in flight. These forces are lift, weight, drag, and thrust. Lift is an upward force created by the wings as air flows around them and keeps the airplane in the air. Weight is the downward force toward the center of the earth, opposite lift, which exists due to gravity. Next, we have thrust. This is a forward force generally created by the aircraft's propellers or turbine engines, which pulls or pushes the aircraft through the air. Finally, there is drag. Drag is the force acting in a direction opposite of thrust, which fundamentally limits the performance of the airplane. When an airplane is maintaining its heading, altitude, and airspeed, it is said to be straight level or an accelerated flight. In an accelerated flight, lift equals weight and thrust equals drag. Talk about flight controls. The flight controls consist of various surfaces around the aircraft that manipulate the aerodynamic forces of the plane, allowing the pilot to control the aircraft. Aircraft flight controls are broken into two systems, primary and secondary flight controls. The three primary controls are the ailerons, elevator, and the rudder. The secondary flight controls are the flaps and trim. Ailerons are located at the back end of the wings and control the aircraft in roll or longitudinal axis. When the pilot moves the controls to the left aileron is deflected up, creating a downward force. And the right aileron is deflected down, creating an upward force, which results in the airplane rolling to the left. The opposite happens when the pilot moves the controls to the right. The elevator is attached to the back of horizontal stabilizer and controls the airplane's pitch, which allows the airplane to climb or descend. Finally, the rudder, which is controlled by the rudder pedals and attached to the back end of the vertical stabilizer, controls the airplane's vertical axis that allows the nose of the airplane to slide to the left or right. Flaps are primarily used to help increase lift during takeoff and landing. This allows the airplane to fly at lower airspeeds and make steeper approaches to landing. Trims are used to make the pilot jobs easier. It allows the airplane to essentially fly itself with fewer control inputs by the pilot. It helps the airplane to relieve pressure. Now, let's go to the major components of an aircraft. We have 5 major components of an aircraft. We have the fuselage, the wings, the empennage, the landing gear, and the power plant. Fuselage is the main section or body of the airplane. This is where you'll find passengers, cargo, and the flight crew. The fuselage is the foundation for the structure of the aircraft. Most airplanes manufactured today use something called semi-monocoque construction. This means that underneath of the skin of an airplane, there are a series of bulkheads and other supports that help hold the airplane together. Well, since we're talking about the aircraft fuselage construction, I will going to pull Don Luisito again from the earliest times to present the 3 types of aircraft construction. Nice to see you again. For aircraft construction, we have truss structure, monocoque, and semi-monocoque. Truss structure is a fuselage design made up of supporting structural members that resist deformation by applied loads. This type of structure is still in use in many lightweight aircraft using welded steel tube trusses. Monocoque construction was pioneered in aircraft by Eugene Brichonnet, with early designs appearing circa 1916 and entering wide use in the 1930s. Monocoque is a structural technique in which stresses are reacted by a thin membrane or a shell of material, rather than a collection of beams. Such structures are stiff in bending and light, and are therefore ideal for lightweight sensitive vehicles such as airplanes. Semi-monocoque is a fuselage design that includes a substructure of bulkheads and or formers, along with stringers to support the flight loads and stresses imposed on the fuselage. The wings of an aircraft serve the same purpose as the wings of a bird, hence their name. Airplanes are considered fixed-wing aircraft. Helicopters are considered rotary-wing aircraft. Wings include ailerons and flaps. There are also 2 kinds of wings that can be distinguished by the number of wings. A monoplane is a fixed-wing aircraft configuration with a single main plane and has inherently the highest efficiency and lowest drag of any wing configuration, and is simplest to build. While a biplane wing structure has a structural advantage over a monoplane, it produces more drag than a monoplane wing. There are also 2 types of wing construction. Externally braced wings, also called semi-cantilever wings, have wires or struts to support the wing. full cantilever wings have no external bracing and are supported internally. The empennage is located by the tail end of the aircraft. Its two main components, the rudder and elevator, help with the stability of the plane. The rudder helps the aircraft steer from right to left, and the elevator helps with changing elevation. You can't have a safe plane without having the landing gear. Not only are these parts imperative to land, but the landing gear is also used to help an aircraft take off and taxi. The landing gear includes shock absorbers for a smooth landing and takeoff, as well as the wheels on the plane. There are common types of landing gear. It could be a set of wheels. It can also be equipped with floats for water operations or skis for landing on snow. Landing gear usually comes in three basic wheel arrangements: conventional, tandem, and tricycle type. Beyond this, landing gear is then classified as either fixed or retractable. Fixed landing gear hangs underneath an aircraft during flight, whereas retractable landing gear is stowed inside an aircraft during flight. The last major component of an aircraft is the power plant. The power plant of an airplane structure includes the engine and the propeller. The engine itself is a complicated system composed of many smaller parts like cylinders, fans, and pistons. Together, these aircraft engine parts work to generate power or thrust of an aircraft. There are various intricacies in the power plant assisting in powering the aircraft, such as various aircraft fuel system components. Basically, there are two models of aircraft power plant: the gas turbine and the piston engine as the power source for aircraft. Each of those engine models can be subdivided into more specialized types, and this will depend on the application and aircraft model where the engine is to be used. Now, let me go back to the question: how do airplanes fly? Airplanes fly because they are able to generate a force called lift, which normally moves the airplane upward. Lift is generated by the forward motion of the airplane through the air. This motion is produced by the thrust of the engine. Therefore, the key of an aircraft to be able to fly is lift. Looking at a cross-section of a wing, we can be able to understand how the lift generates. A wing is a type of airfoil that generates an aerodynamic force as a fluid. In our case, air moves around it. In addition to the wings, all the flight control surfaces, as well as the propellers, are considered airfoil. The aircraft's fuselage also has an airfoil, but it's not as good to produce lift. There are few parts of an airfoil. The forwardmost point of an airfoil is called leading edge. The aftermost point called the trailing edge. If we connect this together with an imaginary line, this line is called chord line. As an airplane flies through the air, the path that the plane travels along is called the flight path. The air that flows through the airfoil as it travels is known as relative wind. Therefore, as you can see, the relative wind is parallel to but opposite to the flight path. The angle of the airfoil's chord line and the relative wind is called the angle of attack. The angle of attack is the major factor as to how much lift the wings generate. Now that we know how the airplanes fly, let us know how the airplane stays in the air. The airplanes stay in the air because of one single fact: there is no net force in them. And with no net force, an object at rest stays at rest, and an object with motion remains in motion, even if it's mid-air 10 kilometers above from the Earth's surface. But it's not like there aren't forces act on the airplane. Well, gravity pulls down the airplane in itself, plus the people and the cargo inside, and the thrust created by the engines, and even the molecules of the air collides the fuselage and wings of an airplane and pushes the airplane as well. But if we balance this particularly, we will get the term weight, lift, thrust, and drag. Now, the main reason why airplanes fly It's basically because of the design of airfoils. Like I said, airfoil-shaped surface can be found on the airplane wings, tail, and propeller blades, or even the fuselage itself. The Bernoulli equation states that an increasing velocity leads to a decrease in pressure. Thus, the higher the velocity of the flow, the lower the pressure. Air flowing over an airfoil will decrease in pressure. The pressure lost over the top of the surface is greater than that of the bottom surface, which causes the airplane to lift. With applying Newton's law of motion and Bernoulli's principle of differential pressure, we're going to get defined how an airplane flies and stays in the air.
That's all for this video. I hope that you've learned something today. If you have any insights, comments, reactions, or any information regarding this video, please feel free to comment down below. Again, this is Reden de Vera. Thank you for watching.